Okay, usually when you're finding the antiderivative of a function that has the square root of something that looks like this, or the square root of a squared minus x squared, where a is a constant, or the square root of a squared plus x squared, trig substitution might be a way to go. And the way to remember what to do with trig substitution is that you want to end up doing a substitution where you end up with either one of these three functions, sine, tangent, or secant. So I just remember STS. And we want to set it up so that there's no radical involved in the substitution and that there's no variable in the denominator. If you draw a little right triangle, and in this case, if you think of x squared minus 4, that might be the other leg of the right triangle, where x is the hypotenuse and 2 is one of the legs. And if you sketch a little right triangle like that, where this is theta, then if you try the Pythagorean theorem, you'll see that this leg is x squared minus 2 squared, or the square root of x squared minus 4. So it must be true that using one of these three functions, the secant of theta will not involve the radical because it's the reciprocal of cosine, and we won't end up with a variable in the denominator. So this is our guy right here, secant of theta. Secant of theta equals x over 2. So x equals 2 secant theta. So the derivative of x, or dx, equals 2 secant theta tangent theta. And now this row right here kind of shows you why we do trig substitution, because it allows us to eliminate this radical. The square root of x squared minus 4, if I substitute 2 secant theta for x, I get 4 secant squared theta minus 4. Then we use the trig identity that tangent squared plus 1 is equal to secant squared. If I distribute that 4 times each term inside there and combine similar terms, the 4 and the minus 4 cancel out, and I get the square root of 4 tangent squared theta, which is 2 tangent theta. And so now we've got everything we need to replace this in terms of theta. X is 2 secant theta. That's this right here. The square root of x squared minus 4 is 2 tangent theta. And dx is 2 secant theta tangent theta d theta. Well, look, everything cancels out just about except this 2 in the denominator. And of course, the d theta. So I'm taking the antiderivative, 1/2 the antiderivative of d theta, which is just theta. So 1/2 theta plus c is your antiderivative. But we want to go back to in terms of x. There's different things that you can do, but usually what you'd like to do is involve the original radical in the substitution you're going to do for theta. So if we say the tangent of theta equals this radical over 2, then theta is the inverse tangent of the square root of x squared minus 4 over 2. So there's your answer right there. Okay, there's other ways to do this problem. I think most of them are more complicated than this. And if we go to board 2, here's a way to kind of prove on Desmos that this is the correct answer. If f of x is the antiderivative of this, then if I take the derivative of the antiderivative, I should get what we started with. And on Desmos, we can confirm that the graphs of these two functions are identical. And that kind of proves that this must be an antiderivative of little f. Okay, there you go. I'll include the link to this Desmos graph in the answer. Hope that helped. And if you have any questions, post a comment.